Okay, today we are going to learn what is the alternating current circuit. So in our home, we are actually provided with AC currents rather than using DC current, which provided using battery only. Okay, so what is AC current? So for an AC current, the direction of your current will be changes periodically. So means it will change according to a certain time. So for example, like this three type of AC current. So they will have positive direction and also negative directions. Okay, but in this chapter we will only learn this type of AC current, which is called sinusoidal AC, which is sinusoidal alternating current. So for this sinusoidal alternating current, we can be represented using sine or cos equation. So let's say for the current equation that represent your alternating current by using sine and cos, which is both can be used. So what is this theta? So theta is your radian, which is your the angle of your alternating current. Okay, your angle can be written in terms of angular frequency, which is your angular velocity. So we know that omega, which is your angular speed, or in this chapter in your textbook it refers to angular frequency. So angular speed is actually the rate of change of your angle. The rate of change of your angle means d theta per dt, which is theta over t. Okay, so omega is equal to theta over t. In other words, theta will be equal to omega t. So by using theta equal to omega t, so your alternating current can be written as I equal to I naught sine omega t, or I equal to I naught cos omega t. So using sine or cos is depend on the diagram of your sinusoidal alternating current. If it's a cos graph, so you have to use cos. If you have a sine graph, then you have to use sine equation. So depend on the graph given. Okay, so what is the value of I? So for here, I is actually your instantaneous current. Means that the current at a certain time. While I naught is your maximum I, the maximum value of your current, which is this, I naught. Of course, for your negative direction, there is also a maximum value, but in negative value. Okay, which we call it as amplitude of I. Okay, while omega, just now I already mentioned, which is your angular frequency, or some of the books were written as angular speed or velocity. Okay, while time, t is your time. Okay, now so for an AC circuit, because it is changes periodically, means it will complete a cycle in a certain time interval. So when the AC circuit complete one cycle, so the time taken, so if we want to say the time taken, okay, sorry, the time taken for an AC to complete one cycle, we call it as periods. Just like your wave, because current is also a type of wave, so periods is actually T, the time taken for a complete oscillation or complete cycle. It will be denoted as second. The unit will be in seconds. Okay, so for T is related to your frequency, because we know that this one complete cycle, so the value at here is actually your periods. Okay, this time taken for a complete cycle. So while for T, it can be represented as 1 per F, which your F is your frequency. So what is your frequency? Means the number of cycle in 1 second, or the number of complete oscillation in 1 second. Okay. And then just now you have already know what is angular speed. So how do you calculate angular speed using in terms of F and T? So you know that omega is actually the rate of change of angle divided by the rate of change of your angle. So which is your 2 pi divided by time taken for a complete cycle. So omega is equal to 2 pi T, and also can be written as 2 pi F. So this is also very important throughout this chapter, and this one and this one. Okay, of course, this is represent the current. So in an AC circuit, okay, in an AC circuit, the voltage is also changes periodically. Means it will have positive voltage and negative voltage. So it will be represented using this equation or this equation. So depends on the graph given. If you have a sine graph, so you have to written in sine equation. If you have cos graph, you have to written in cos equation. Same, V is your instantaneous voltage. V will be denoted as your maximum voltage or your peak voltage, or we call it as amplitude of your voltage. Then omega is your angular frequency or your angular speed. T is the time for the AC circuit. Okay. So if you refer to this graph, when there is a question asks you to find the peak to peak value of current. Let's say you want to find the current, the peak to peak value of a current. So the peak to peak means the positive amplitude to the negative amplitude. So the value between these two. So this value in between the positive and negative will be equal to 2 I naught, because I naught plus I naught. So you have peak to peak equal to 2 I naught. Of course, if you want to find the peak to peak value of voltage, so will be equal to 2 V naught. Okay. So now you have to learn what is mean square value of an AC current. Okay, we know that AC current can be represented using this equation. Okay, or I equal to I naught sine omega t. Okay, so we're using theta instead of omega t to simplify our formula, our equations. So mean square means you want to calculate the mean value for the square. So square both sides of your equation. So we will get something like this. So if you want to find the mean square value of the current, so finding the mean value of this will be equal to finding mean value of this. Okay, since I0 is a constant, so we can take out the constant and we have this. So in other words, mean square current of your AC circuit will be equal to I0 square times your mean value of your sine square theta. So how do you calculate the mean sine square theta? So mean sine square theta is actually, if you want to return in to be correct, will be sine theta 1 plus sine theta 2 plus sine theta 3 and etc. until sine. Let's say you want to calculate from 0 your theta, the mean value from your 0 radian to pi radian. So your mean value of your sine square theta, sine square theta, the mean value will be sine square like this, 0 until sine pi divided by pi. Okay, so this, because this value, okay, if you refer back to this graph, so sine square value, this value is, if we want to add up all the value, so we are actually finding the area under the graph, under the sine square graph. Okay, so in other words, these upwards, the sine square, that 0 plus until the sine square pi will be equal to 1 pi integrate 0 to pi sine square theta d theta, because we want to find the area under the graph. So we have this equation. Okay, when you integrate these equations, so means you do your integrations, so you will get 1/2. After you simplify this integration, you will get mean value of your sine square is equal to 1/2. Okay, so you can work out this later. If you really don't understand, you can ask me. Okay, in other words, we have this sine square, mean sine square theta is equal to 1/2. So substitute inside, we will have I0 1/2. So in other words, your mean square value will be equal to I0 square divided by 2. Okay? Well, for your mean square value for your voltage is exactly the same, because you have V equal to V0 sine theta, and you square both sides, you have your V0 square sine theta, and you mean that you have this. So in other words, your mean square voltage will be equal to V0 per 2, which is exactly the same as your current. Okay, so now after you have learned this is mean square, so this is not really important, but the next one you have to be very listen carefully, which is your root mean square. Root mean square value of your AC current, AC circuit. Okay, so what is your root mean square? So this one, root mean square, means we square root the mean square. Square root both sides. So this one, because square root, so will cancel out, so you will get root mean square. In other words, you can denote as r.m.s. And this one, after you square root, you will get I0 divided by square root of 2. Same as your voltage, so your root mean square upon voltage will be equal to V0 per square root 2. So this is your V.r.m.s. So you can be written as I.r.m.s equal to I0 divided by square root 2, or V.r.m.s equal to V0 per square root 2. Okay, so what is actually I.r.m.s and V.r.m.s? Calculation is very easy because only I.r.m.s is equal to I0 per square root 2. So what is your R.m.s value? So r.m.s value is actually the comparison value with your DC circuit. So in other words, if you refer to your page 288, you will see the definition which the r.m.s value of an alternating current is equal to the value of a constant direct current which produce same heating power as alternating current in a resistor. So what is this definition means? So means that, let's say you have your I.r.m.s, you get your I.r.m.s equal to 5 ampere, and your DC current, so your DC is equal to 5 ampere. So of course, because of your AC current, the current that provided inside a AC circuit will be changes periodically. So this I.r.m.s will be equal to 5 ampere, but you have to remember the maximum I for this type of circuit is not 5 ampere, is actually greater than 5 ampere. But this I.r.m.s will consider as a value that have the same power generate through your resistor as your DC. Means the power at here, okay, the power, the P through this resistor will be equal to your power to the resistor in a DC circuit. So if you have I.r.m.s equal to 5 ampere in your AC circuit, so the power that dissipated through this, the heating power, or the rate of change of your heat dissipated, the rate of heat dissipated will be equal to the DC circuit. Okay, means that when you provided IDC equal to 5 ampere, the heat generate or the power generate through the resistor at here will be equal to power that generate from the AC current, which has I.r.m.s equal to 5 ampere. Okay, are you clear? If you don't understand, please ask. So in other words, we have V you need to complete. So please complete exercise 18.1 in page 289. Okay, so after you have complete your exercise, after you have complete your exercise, please snap your answer and send it to me. Okay, thank you.